What is going on, everybody? It is Bucky, and welcome to another amazing tutorial. And in this tutorial, we're going to be talking about a new data type. Now, as you can see, I already deleted all the extra crap that we didn't need in our other tutorial. All I have left is the two object declarations and releasing the objects. But for now, let me just type some crap in here so I can explain. Now, we already learned about some other data types like int that holds like integers like 1, 3, 54. And we also learned about another character data type which stored like letters like W and Y and characters like that. And there's also a whole bunch of other data types. Most of them work with numbers, like some work with numbers with decimal points, some work with smaller numbers, big numbers. But the data type we want to talk about today is a data type that's very important to polymorphism. It's called the ID, or some people call it ID data type. Now, the ID data type is kind of a generic data type. It can store pretty much anything you want it to store. So if you put ID variable, it can pretty much store any variable you want. So again, ID can pretty much store data of any type. It's a generic data type. Now, since it is a generic data type, it not only can work with variables, but you can also, create methods that can, say you have a method called method, and you passed it in a value called apples. It can also have a return type of ID. So again, like you see, this ID data type can pretty much, pretty much do anything. It's really dynamic. But why am I telling you this, and why is this useful for this tutorial? Well, not only can it store, variables and be used in methods, but it can also be used to store objects of any type. It can be used to store objects. So let's check this out. Let's make an ID variable called tuna. See, now tuna isn't equal to anything, but I said that it can store objects of any type. So let's set it equal to the object n. And remember, n is an object from the numbers class. So since now tuna is equal to n, does that mean that we can use tuna to call methods from the numbers class, like print? Let's see if this works. Go ahead and save that, and whoa, check it out. Now we just made this weird ID data type that can pretty much store anything called tuna, and now we made it into a numbers object, and it can actually call methods from the numbers class. That is pretty cool right there. But say we were tired of that, and we want to set tuna equal to an object from another class. We want to set it equal to a member from the characters class. So does this mean we can actually change it halfway through our program and call methods from the characters class? That would be crazy if we can do that. Let's go ahead and build and run that. Save, and whoa, check this out. Halfway through the beginning of the program, the same object belonged to the numbers class, and then halfway through it switched, and now it started calling methods from the characters class. That is pretty cool right there. That is some pretty awesome stuff. So I know you're saying, alright, if you put tuna print and it did this, and then put tuna print and it did something else, how does it know exactly what print to do? Well, check this out. Whenever you call a method from any object, it's built into your system what class that object belongs to. So currently, right here, this object belonged to the numbers class, so that's why I called the numbers print method. And later on, when we changed it to C from the characters class, this tuna object now belonged to the characters class. So that is why it called print from the characters class. So the cool thing about this is with polymorphism and the ID or ID type, this one object can access methods from as many different classes as you want it to, and you're not only restricted to one object accessing one class's methods and variables. So that is the beauty of polymorphism working along with the ID type. So let's see if there's anything else I want to that's pretty much it. So this isn't really useful in this program right here. This is because I just gave you guys like the most basic bare bones example I could. But where in the real world programming would you use this? Well, let me give you guys a quick example. Say you have a bunch of different classes for a bunch of different shapes, and you say circle, square, triangle, rectangle, octagon. All of those classes had methods in them called draw, and when you called the method draw, it would either draw a circle on the screen, or a triangle, or a rectangle, depending on what method or what class you were using it on. Well, the cool thing about this is you could set Tuna equal to objects of each of those classes, and just by putting Tuna draw, it might draw a circle. Tuna draw, it might draw a rectangle. Tuna draw, it might draw a triangle or an octagon or anything else. So later on you can see that instead of having a bunch of different objects do it, it's going to be easier just to have one object loop through and call that one method, and it will do a bunch of different things depending on what class it belongs to. And I know that's confusing right now, but I thought I'd give you guys an example. But for now, thank you guys for watching. Don't forget to subscribe. I know this may seem confusing, but when we get programming later, it'll clear it up for you. So if you have any questions, ask me on my forum below. There's a link to all the source code from this tutorial below in the link. Thank you guys for watching. Don't forget to subscribe, and I will see you next tutorial.